C2H4 is another organic molecule, carbon and hydrogen. I've already done the electron count, so 2 carbons, 2 times 4 gives us 8, 4 hydrogens gives us 4 electrons, so we have a total of 12 electrons to work with. We can make the assumption that the molecule is symmetrical in the sense that each carbon atom is going to have 2 hydrogens. So I'll put them like this. Now what do we need to do? We need to connect all the atoms with single bonds. So the order doesn't matter. So 2, 4, 6, 8, 10. Okay. Well, we're left over with 2 electrons. I could try putting in a lone pair, but very quickly that'll become obvious that it's not going to work because we'd have an octet rule violation. So I have 2 electrons. Well, that gives me a double bond. Octet rule is satisfied for carbon. Hydrogen obviously doesn't have to satisfy the octet rule. What about Vesper? What about the overall structure? Here's where things get interesting. These bond angles, hydrogen, carbon to hydrogen, are approximately 120. When you have a double bond in a molecule, that can distort the bond angle to a certain degree. So we would estimate that these bond angles are in that ballpark of 120, but we'd actually have to measure it to know exactly what it is. I'll put this one. And it would be the same for the other carbon, the other side. However, the name of the geometry, well, for the carbon, each carbon, I should say, it's going to be trigonal planar.